Right. So we're gonna be looking at what all waves is experience. So wave phenomena. That's the topic. Wave phenomena. Now we specifically gonna be dealing with light waves, but sound is a wave as well. Aliyah, tell me if you see any others in your life. So all waves, all waves is experience number one, refraction. You know what refraction is, Aliyah? Good evening, Kristen. Yeah, Aliyah, you know what refraction is?
Unfortunately, no.
What about reflection? Yeah, I don't know reflection.
Refraction, yeah.
All right. The next one is interference. And have two types of interference. It have constructive and destructive. And lastly, it have diffraction. All waves is undergo these phenomena, right? All waves. So the first one we're going to be looking at, unsurprisingly, is refraction. Right, so copy that down. Yes, so Nicholas not here. Is he here, guys? Is Nicholas here?
Nah,
No, not so yet. Okay,
see Nicholas not dedicated to the physics.
see that, see that. Well, you know what? Do you know what refraction is? Taken as I know.
Ah, nah.
All right, fraction is. Aliyah, you ever went in a river or a pool or something, and you look at your friend and their legs all kind of looking weird and they're looking extra short when like one part of their body looking short in the water. You know what I'm talking about?
Yeah.
That's because of refraction. Basically, what has happened, right? Max, that question. You just move faster in air or water. We could run faster in air or water.
In air.
So where you think light is travel faster in air or water?
Air?
Yeah, correct. So when the light rays enter water, they get refracted, they bend. And that's because the light traveling at different speeds in the air versus in the water. That's what refraction is. Simple as it is. Right? Justin, you understand that?
Yeah.
Right? So refraction refers to the bending of light rays as a result of change in medium. And you would need to know the laws of refraction. Aliyah, I could already imagine your face. You will see. I could already imagine it. You're gonna be like, nah, man, when you see these rules. But I find everybody so real quiet today. Justin, you have this copy down? Everything so far?
Yeah.
Okay, cool. So let me look at the laws of refraction. Number one. And I'm going to show you guys what the normal and thing is just now. I just writing down these things. The normal right? So, Justin, as I write away, it's a call out. So, I want you to read the first law of refraction.
First law,
Yeah.
the normal is always perpendicular to the boundary line.
Probably saying, nah, boy, I cooked. What is that about? Normal? That's how me feeling normal.
Yeah.
Hmm. It'll be all right. The second rule makes sense. Um, light waves bend when they pass through. So today I want to do refraction and reflection. Right? So light waves bend when they pass through different mediums. And Aliyah, why you think the light waves bending when it goes to a different medium, like a different substance? Why is that?
Because the surface, not the surface.
On the surface.
I don't know if that's the right word. That's not the right word.
Think about the
Um,
example if it were you running in air versus you running in water. Think about that.
the it does change. Like
What what has changed?
I don't know the word. I don't know how to say it.
Hmm. The reason it is the reason it does bend is because you have light traveling at two different speeds.
Right.
Because in air, it traveling fast, right? It traveling at 3 by 10 to the power 8, but in water, the speed slow down, right?
Yeah.
So light waves bend when it pass through different mediums as a result of light traveling at different speeds. Justin, I don't know about Aliyah, but it does run faster in air or water.
I mean, air,
Yeah, for sure. So what you think, see, so like denser the substance, you think you go run faster or slower?
slower,
Right. And the same thing is applied for light. The denser the medium, what you think is happening to light?
it moves slower.
Right. And it will bend more. It will bend
Yeah.
more. The denser it is, the more the light will bend. I put on some notes for you just now. Right. So light waves bend when they pass through different mediums as a result of light traveling at different speeds. Did you know what refraction was before like this?
Not so in detail.
Hmm. And we just call this relationship Snell's law. You ever hear about Snell's law before?
No.
What? All right, all right.
I mean, you know who's my teacher, so
But I might G, he cool. But he never taught me before, so I don't know.
he cool, eh? Just I don't like his teaching styles.
Hmm.
Because anytime some a question in class, like when he do a question, he's had to Google the answer.
No way. No, that's crazy.
Like if he had know it on the top of his head, he's had to go on Google on the phone and Google the answer.
Well, sometimes I had to do the same thing, to be honest.
I
I
mean,
I don't know everything. I young, I don't know everything. So if I don't know something, I just Google it. And everybody know everything. Holy man for that. Is if we doing it every single time then?
Well, that is itself. As every time.
Hmm.
Could be the same question over and over, and it's the same thing. You keep Googling it.
Oh my gosh. All right, so Aliyah, let me know if you understand all the laws so far, minus the first one. You're probably confused by the first one.
Yeah.
Okay, cool. Kirsten, you ever do this before? Snell's law and thing? No? All right, well, you're learning now. Justin, look who arrived. Aliyah, look who finally arrived. Let's see, and that's
Nicholas.
Listen, good afternoon. How are you doing?
um we're going real good. Real good.
Right, yeah, that will.
Hmm. You finish refraction and thing as yet?
Yeah, we finished it, I think, earlier this term, like at the start of the term. We're doing labs on it now.
All right, no problem. All right, so laws of refraction. The normal is always perpendicular to the boundary line. Light waves bend when they pass through different mediums as a result of light traveling at different speeds. This relationship is known as Snell's law. You had to know about refractive index, right? Uh, so you need to know what refractive index is as well. Oops. Index. So,
So what do you think? That would be a good match to watch?
what is it?
I said that would be a good match to watch between me and what's your name, Aliyah?
Yeah, that'll be a good match. Don't underestimate Aliyah, though, Aliyah.
As I say, I get proof to prove it.
Mm-hmm. So, Nicholas, let me explain a little bit of what's going on here, right? Um, First question, you just move faster in air or you just move faster in water?
Yeah,
Waiting light is move faster in.
light would move faster and air.
Right. The denser the medium, the slower light will move. As such, it will bend, it will bend away more. You understand that?
Yeah, I understand now.
Right. So I just put down some things you need to know before I jump into questions and things. So N stands for the refractive index. Anywhere you see N, that's your refractive index. So the refractive index is just a ratio between the speed of light in air compared to the speed of light in the other medium. Um, Aliyah, make a wild guess. You think light is being refracted in air? Like if it's in air, you think the speed slowing down or just by moving at the original speed?
It can move at the original speed.
Right. So because that is the case, the refractive index of air is just one. If you multiply one by anything, we'll get 5 by 1. It's 5 by 1.
5.
Right. So the refractive index for air is just one. That means the speed of light isn't changed. Another formula for refractive index is, let's show you another formula. So that is, does anybody remember what that symbol represents? That funny looking symbol. Justin, you know what that symbol represents?
With some the I think wavelength then.
Yeah, yeah, that's wavelength. Right. Right, so copy this down and I'll jump into the theory and I will explain everything. Clear up all the confusion. Right, so Alia, as soon as you have that copy down, you'll let me know.
Okay, I'm almost done.
You just still make your notes look pretty and thing, like different colors and thing or not.
Yeah.
Okay, okay. Nicholas, I feel like you just real make your notes colorful, you know. Cough, cough, cough,
And
cough. I choke him,
in
but
all of my subjects and thing,
you just use black.
well, I sprung off them one pen, the only pen I have in my bag, blue. So, yeah,
All your notes will be one color.
I
yeah,
don't know
all
if
my notes
could,
is just one.
I don't know if people could do that.
Same, man.
Too much colors is hurt your eyes. It doesn't let you learn properly.
I find it has helped me learn.
Nah.
I like to see the colors.
Yeah, yeah, for sure.
It has helped me.
It is help you like distinguish between different things, you know,
Yeah.
for sure.
Only different color you can see me using is blue, black, and red.
He
I could
he's
only use I could only ever use red to correct. I don't
Nicholas
know.
basic. That's okay,
Is that?
right? So wait, huh? Justin, I find you real quiet today. You all right?
See?
Yeah,
Yeah, good. I know. Well.
all right. Yeah, as soon as you have his copy down, just let me know.
Yeah, I finished a long time.
All right. Um, who's still writing?
Hold on, are they on the red part, the last red part?
All right. So anytime I see N, that's refractive index. If you want, you could also copy down this. Um, refractive index of E equal to 1. Sometimes you can see they're writing with a small, like a very small thing by the end, like Na. That means your refractive index of A. That'll be equal to 1. That has never changed, right? Because Nicholas, um, one light moving in air, you think the speed change, you know, is like constant speed, 3 by 10 to the power 8. Like if
Me?
light moving in air, yeah, if light moving in air is easy.
If like moving in here, then it remain the same speed.
It's only when it changes medium, it will change speed. Yeah.
Yeah.
Are they having a hard time making up our rights? Find a writing rules.
No. Nah.
Okay. Aliyah, you just watch Bridgerton?
What was that?
If you watch Bridgerton,
Yeah, I watched out.
how that feeling, you know? I feel like Tatiana's real watch them thing, but she just don't tell anybody, you know. I feel so. Like Sasha, I have a girly side, you just can't see it.
Yeah, me too. I feel so.
All right. So, Nicholas, yeah, I have everything copied down.
Yeah.
Okay, time to explain what exactly everything means. So, Aliyah, I want you to call out the first rule, right? Because I'm going to explain the first rule now. Call back the first rule.
Um, the normal is always perpendicular to the boundary line.
Right. What does the word perpendicular mean? Come on, Aliyah. Aliyah doing maths and thing. Aliyah can't know perpendicular.
Always meet at a right angle.
Right. Aliyah, did you know that?
Yes, I did.
You was right.
Uh-huh.
No,
I
I can
do
tell
know
stuff
that.
here. Hey, right? So let me
It
get an
took
example.
1 second.
Let me draw a glass cup here. Can a half crack glass cup here? Can I bend out? Oh Lord. We will live with it. All right. So let me just say over here is water. Aliyah, trying to be aesthetic here. Try nothing. Or they don't have to draw it so fancy and thing, but I just one
So
time.
you forgot as an artist too.
Yeah, he's an artist. You could draw it fancy and thing.
Right.
So let me explain what's going on, right? Aliyah, all this over here, what is this? What is that? Eh, what is that?
A,
That's air. So this whole thing over here is air. And over here, what is this?
that's the water.
Right? When I put a straw, let me just say I put a straw in the water.
Mm-hmm.
That straw not the straw not gonna look like this, eh? The straw not gonna look like this. What gonna
No.
happen is the straw might look out something like this. When you look at it from the water, it might look a little bend like that. You
Yeah.
understand? So let me show you what's going on. You see, you see this line here? The line that separates the air and the water.
Mm-hmm.
We call that the boundary line. That's the boundary that separates the air and water. Boundary line. And the boundary line separates the mediums. This, right? And now time for the normal. Now, Elia, perpendicular. Just remind me one more time, what does perpendicular mean?
Always meet at a right angle.
What is that right angle?
90.
There's 90 degrees to the boundary line.
No.
How about this?
Yeah.
Yeah. So the first rule says that um the the normal and the boundary line, they have to be perpendicular to each other, like so. So the blue line, that's the boundary line because it's separating the two mediums. And the green line, we call that the normal, right? That's the normal. So Aliyah, you understand everything so far?
Yeah.
Right. Justin, how about you?
Yeah, easy thing.
All right. Now, you have two terms you need to be acquainted with, incident ray and refracted ray. The incident ray is what is coming from the air, right? Aliyah, let me know if that makes sense. So incident is what coming from the air and they're gonna hit the water. Let me know if you understand.
Yeah.
So I have a light ray, it incoming, and that light ray, it gonna hit that boundary line, right? And we're gonna measure that angle from the normal, like so. And we're gonna call this the angle of incidence, theta I. That is the incident angle. Incident angle is always measured from the normal, always measured from the normal, right? And well, Aliyah, when that incident ray hit that boundary line, you think you're gonna pass straight through like that? Tell me if you think the light ray will just pass straight through like that. Tell me what you think, Aliyah.
Um.
Tell me if you think the light ray will just pass straight through.
Yeah.
Think about the example with the straw. When you pass straw in water, what's happening?
It does go into the water. I don't know.
Let me show you what I'm talking about. Is the speed of light in air the same speed in water? Come on, Aliyah. Where would
No.
light travel
So
faster?
it would slow down.
It goes so long, and because of
Yeah.
that, the line it will bend.
Yeah.
It will bend. Let me show you what I'm talking about. That's what I'm talking about. Check, check. All right. So, Aliyah, you agree that it wouldn't just go straight through, right? Because the speed of light changing.
Yeah.
Right. Now, which one is denser? Air or water?
Water.
Water. So the light ray, it will bend towards the normal. Let me explain what's going on. So you have your incident ray here. This is your incident ray. We call this the incident ray. Get some space. We call this the incident ray. And after it hits the boundary line, the new angle, again, we always measure our angles from the normal, and the normal is always 90 degrees to the boundary. And we call this thing over here the refracted ray, right? Because Aliyah, when it hits the boundary line and it is now in water, it's not moving at the same speed, right? It's not moving at the same speed. Tell me if that makes
No.
sense. Not moving at the
Yeah.
same speed. So we call that the refracted ray. Simple. The reason why we call it that is because the light ray, it was refracted, right? Theta I, we call that angle of incidence. Justin, that picture is on the chat that ever happened to you?
Yeah.
Yeah. So I'll give you also more examples, don't worry. Um, Nicholas, you understand everything so far?
Goes up?
You understand everything so far?
Yeah, yeah, I understand. This easy thing.
All right, nice.
So to the Kira girls come back to prove herself today.
She could join, you know. She could join. I thought she could
Mm.
join.
She knows she has studios like me and Nicholas, so she want to join.
I feel so. I feel so.
Nicholas, yeah, say hi.
I feel so.
Productive. So this piece of thing over here will change all their lives. Like if for this topic at least. Only for they hear this, but this this will change your life. So we had denser medium, and then we have less dense medium. Right? Right. Ali, I have everything copied down to this point.
I almost done.
Right. So if you go into a denser medium, your refracted ray, it would bend towards the normal. Right? So Aliyah, if you notice, that is what happened. Which angle you think bigger? You think the angle of incidence bigger? You think the refracted angular refraction bigger? If you had to guess. Make a guess. You go into a denser medium. So what do you think bigger? Angle of incidence, the angle of refraction.
The angle of incidence.
Yes, because when it enters the water, it's gonna bend towards the normal. So that angle gonna get smaller. Yeah. Um, Justin, give me an example of something denser than water. I like it pass through. Justin, you could think of anything that light could pass through, like it clear and it's denser than water.
Um, nah.
Nah. How about glass? And light
Oh,
could pass
yeah,
through glass.
yeah.
Yeah, light could pass through glass. Mm-hmm. Yeah. So copy this down and I'll explain some more. Right, and I want to later just remember this. Moving on. You had to remember that moving on. If you go into a denser, it will bend towards the normal. If you go into a less dense, it will bend away. You gotta remember that. So Justin, I just want to run through the concept with you, right? Um, when the light ray, first of all, you understand what the boundary line is? Let me know if you understand what the boundary line is, Justin.
Yeah, I understand.
See if you can explain what the boundary line is. So,
So like for the water and energy, so the boundary line will be the line that's separating the two elements using, so like the water and the air.
yes, yes. And when light hits the boundary line, what happens to the light after that point?
It bends a little bit.
It go bend. Now,
Yeah.
since it go into a more dense medium, that ray go bend away from the normal or towards the normal. It go
Towards the normal.
correct. So, which angle bigger? Is it the incident ray? Sorry, is it the angle of incidence or is it the angle of refraction? Make a guess.
Angle. The angle of incidence.
Yes, that bigger. That's bigger. Okay, seems like you understand the concept there, right? You
Yeah.
got everything copy down.
Yeah.
Houston, drop in the chat. Let me know if you have everything copied down. Nicholas, Alia,
Yeah, however,
let's look at some more examples. So in questions, this is the way it typically looks like. I'll give all the example. So they have a boundary line AB, right? Could somebody show me what the normal would look like? If this is my boundary line, this over here is my boundary line. Could somebody show me where my normal will be situated? I want somebody to show me that. Just draw a line. I'll wait till somebody, Justin. I'll wait to show me what the normal is. Show me how the normal would look like.
Making a wild guess, Maybe.
Over there.
Yeah, I'm making a guess.
hold on, let me see how they get.
So the normal is always perpendicular to the boundary line. This line over here, let me give you an example. Like we just say over here is air and over here is water. So that line AB, it's separating those two, right? It's separating those two. So the normal has to be
Okay.
perpendicular. Had to be perpendicular, means 90 degrees to the boundary line. So all Leah is drawing there is correct.
Okay. She proved me wrong.
Right? And we call that the
Thank you very much.
That is in physics, not cricket.
so Justin, if you have anything that confusing you, any slightest, just let me know. Just let me know.
Nah, I mixed it up. I mixed it up.
So we call this line over here, we call it the normal. Why is it the normal? It's what to the boundary line. What angle?
Perpendicular to the boundary line, 90 degrees.
Correct. We call this the normal. I want somebody to draw an incident ray for me. An incident ray. There's a light ray that coming in and it hit any normal. It can hit it anywhere. Anybody.
I'm gonna try and prove myself.
See,
Redeem yourself.
bef okay, that we could work with that. Yeah, we could work with that. All right, so like here, I want you to show me how would I measure the angle of incidence? How would I measure the angle of incidence?
The angular incidence will be day.
Yes, it's always measured from the incident ray and the normal, always. And let me, what angle that looking like? Make a guess. What angle that looking like?
About 45.
45, all right. Now, here what? It going from air to water. Which one is more dense? This,
Water.
this is not a trick question, eh? Water is more dense. So, let me ask you a question. Or let's think the light ray go continue moving at the same speed and just go straight through. Or let's
Then I
think
go bend.
it go bend, right? And since it going from a less to a more dense, it will bend towards the normal or bend away.
One to one to know what?
Right. So which angle you think bigger, the angular incidence or the angular um refraction?
Angular incidence.
Angular incidence will be bigger, right? And let me just say that this over here is well, let we actually find it, right? Let we actually find it. I'm gonna show you how to use the formulas. Um, it had some formula, Snell's law. Can somebody just remind me what Snell's law was? Can somebody remind me what Snell's law was? I'll take that on, right? This
Yeah.
was
It was the speed of light in air over the speed of light in the medium.
all right. That formula is for refractive index.
So no.
Not a formula.
Um,
This formula
tell me
is
if I'm correct here, but and Snell's law is the incident ray, the refracted ray is on the same like the same thing.
nah, it's a formula. This is the formula I'm talking about.
Or
Anytime you have to do a calculation with this, you have to use Snell's law anytime, right? And typically, they will give you the refractive indexes. So the refractive index of air, the refractive index for air, what is, guys? If light do refract in air, what do you think the refractive index is? Tell me, Alia, what do you think the refractive index in air is? Light do bend in air. What is a number that don't change anything? Tell me, Alia, what is a number that don't change anything? One.
One.
The refractive index in air is one because light is travel at the speed of light in air. At full speed, one, right? In water, the refractive index is 1.30. The higher the refractive index, the denser the medium, and the slower light is traveling. Right. So guys, some of them might get lost. I hope I don't lose. I hope I don't lose all there too bad. All right, Justin, I'll wait to handle this question with me.
All
Justin.
right.
So Ni, that refers to my refractive index for the incident ray. So my
Right.
incident ray, it was in what? Where was it? My incident ray. Where that was? In water, air,
It was in air.
air. And what is the refractive index for air?
45.
Nah, one. N is equal to one,
Oh,
right? And this I, that I stands for the angle of incidence. What was my angle of incidence? What was the angle of incidence? That is the angle formed between the incident ray and the normal.
45 degrees.
That was 45, right? Next part of it. What was the refractive index after it passed the boundary line? That's over here. That is water. What's your refractive index of water? I give you any question. Refractive index is given by the symbol N,
Oh, wow, 1.30.
right? And do I know what the angle of refraction is?
No.
Nah, so I'll leave it as sine R. Aliyah, you understand everything so far?
Yeah.
All right. So what is 1 by sine 45? What is 5 by 1?
5?
5. So 1 by sine 45, that's just sine 45. So I have sine 45 is equal to 1.30 sine R. Now, for me to find for R, I had to get rid of the 1.30. So I'm gonna divide both sides by 1.30. That's what I'm gonna do. I'm gonna divide both sides by 1.30 so that this and this will cancel off. So sine R is equal to sine 45 over 1.30. And Justin, if I want to find for R, I had to do what?
Divide by R.
Nah, I had to find the inverse
Oh,
sine inverse.
multiply by R.
No. If I want to
Uh,
find for R, I will find sine inverse.
Oh, yeah.
Aliyah, and this is what we do in math class. Sine inverse something. Remember sine inverse?
Yeah.
So if you want to find pi angle, you have to find the inverse function. So sine inverse. It will be in all the calculator, right? I will send all a video on how to do it on Sharp and Casio. So the angle R would be sine inverse of sine 45 over 1.30. So Justin, into you have a sharp?
Yeah.
Shucks, I know how to sharp up now.
I know how to get the I think I know how to get the sine inverse.
All right. Well, plugging that from a guy, sine 45, sine inverse of sine 45 over 1.30. I was sending out a picture of it.
I
Sharpness.
get I get 32.95.
Okay, that's impressive. And that's with our sharp.
It's a long decimal, but I get 32.95
Right.
to simplify.
And tell me if that makes sense. So they're saying that the angular refraction is like, that's basically 33. Tell me if that's what we was predicting.
Yeah, yeah, they say about 30, so yeah, around it.
Right. And remind me, if it if it going from a less to a more, it go bend towards the normal. So which angle will be bigger? The incident, angular incidence, the angular refraction. Which angle will be bigger all the time? You want to say that back one more time?
Yeah.
So when it enter the water, water is more dense or less dense?
More dense?
More dense, so it go bend towards the normal. So if it bending towards the normal, which angle will be bigger? This one or this one? One or two?
One?
One will be bigger. And according to the calculations, was that true? Was this bigger?
Yeah.
Yeah, it was bigger because we found this to be 33 degrees approximately. I feel like I gotta run through back that calculation one more time, right? Because that's the maths aspect there. Aliyah, did the calculations confirm our predictions?
Yeah.
The calculations confusing you?
No,
No? All right.
no.
Nicholas, what about you? The calculations confusing you in any way?
No, no, good.
All right. Justin, I feel like the calculations throwing you off a little bit.
Mm, not really.
But for the sake of anybody, for everybody, I'll explain back one more time. So, Justin, let me run through this one more time. What do I call this? This over here. That's my watch ray,
The incident ray,
right? This angle over here is called the angle of,
incidence,
yeah, the angle of incidence, right? This over here is called the,
boundary line,
right? This over here is the refractive index for,
air,
right? And is one. This over here is the refractive index for,
water,
right? What do we call this,
the refracted ray,
right? And as what's happened to the ray after it passed through the boundary line. And what do we call theta r?
the refracted angle,
Hmm. Proper thing is the angular refraction. Angular refraction. Just remind me, if you're going from a less dense to a more dense, what has happened to the angle? So what's happened to the refracted ray? It
and
go
go bend more to the normal,
right. So in situations like this, which angle will always be bigger?
the incidence angle of incidence,
Perfect. Well done. Calculations aspect now. So Ni, anytime you see N, what does N stand for? N stands for what? Anybody know what N stands for?
refractive index,
Right. That's your refractive index. Justin, you said that, right?
yeah,
Right. And it's the refractive index for the incident ray. The incident ray. Where is the incident ray?
in air,
This is air. So the refractive index for air is 1. So I plug in 1. You understand?
yeah,
Then sine the angle of incidence. My angle of incidence is 45. The other part of the equation, NR. That's the angle of refraction. Sorry, not the angle of refraction. That's the refractive index for the refracted rate. Where's your refracted rate, Justin? Where's your refractive?
in water,
Where's your refractive index of water?
1.30,
Yes, 1.30. Right? And R, that stands for the angular refraction. Do we know what that is up to this point?
no,
Now, so we're trying to find things. So this is the math aspect. 1 by sine 45 is just sine 45, right? You understand?
yeah,
I want to find for sine R first. So what's in front of sine R? What's in front of sine R?
1.30,
1.30. And that is 1.30 add sine R, multiply by sine R. Wait a
multiplied by sine r,
So where's the opposite of multiply?
divide,
All right, and we could divide, so you could cancel off. So when we do that, we end up with sine R is equal to sine 45 over 1.30. I want to find, remind me, any question, I wanted to find for what angle? Angular what?
refraction,
Right, so that is R. So to do that, I would have had to find sine inverse at this whole thing. And I get 33 degrees. Bam. Leah, you understand this question completely?
Yeah,
I think Bryce will get this pass.
really?
Yeah, I feel so. Yeah.
I
Um,
don't know.
well, Nicholas, you know this already. I take it you understand everything.
Yeah, I understand what you mean.
Let me look at another example. But instead, let me go, let me change up things a little bit. I'll change up things a little bit. All right. So Aliyah, where you want me to go to? You want me to go from glass to air, water to glass? Where you want me to go to? Come on.
Glass to air.
Glass
You
to
mean
air? Glass to air? Okay, I could do that. I will do glass to air. So you said glass to air, right?
mm-hmm.
So that means where was I originally?
Air?
Now you said glass to air.
Oh yeah.
So that mean
Glass.
I coming from the glass, right? That
Yeah.
can mean you shine a light into glass or something, whatever the case is, right? Now this is a bit different, but it's a good example nonetheless, right? Just remind me, where's the refractive index at air? What does always be?
1.
That's V1. And well, the refractive index for glass is 1.5. Since you are going from glass to air, this is your angular incidence or your angular refraction. You're coming from
Um,
and going to air.
that'll be angular incidence.
Correct. Because that's where you're coming from.
Yeah.
Right? And you're going from a more dense to a less dense to a more dense, or going.
More than star less than.
So is it gonna bend towards the normal or away from the normal?
To what?
Check back the notes. So look at what's going on, right? Which one is more dense? Glass or air?
Glass.
So we're going from a more dense to a
Less than. So bend towards the normal.
you sure? More dense to less dense?
More than, yeah. No.
Going
Wait.
to less dense medium.
Oh, okay. So bend away from the normal.
Correct. It will bend that way.
Wait,
So
so if it was from air to glass, then it would have been towards the normal.
correct, because air
Okay.
less dense than glass.
Okay.
So you're going from glass to air. Now you're going from a more dense to a less dense. So let's say operates over here. The refracted ray will bend away from the normal. It's like the refracted ray saying, brother, ew, to the normal. It's like, no, we are walking by you. You kind of,
Yeah.
yeah. So what's gonna happen, right? Would it pass straight through a lion? Would it pass straight through? Like, would it just go straight through?
Um, yeah, because the speed because the speed will speed up.
It goes speed up, right? But does that mean it's
But
gonna just go the same direction?
oh no. No.
It go bend.
Yeah. It will bend more
It go bend towards the medium. Sorry, it go bend
away
towards the
from
normal or away from the normal.
it will bend away from the normal.
Right. So in this situation, one angle will be bigger than one angle you think will be bigger.
The refraction.
Angular refraction.
Yeah.
That's because it bends away from the normal.
Away from the normal. Yeah.
Right. Justin, you understand everything so far?
Yeah,
So you're going from glass to air. Which one more dense? Glass or air?
glass.
Glass. So since it coming from glass, that's gonna be an incident ray. Wherever you're coming from, that's the incident ray.
Right.
and you're passing through the boundary line and you're going into air. Because you're going into air is less dense. So you're gonna bend towards the normal or bend away from it.
Away.
So which angle will be bigger? Theta I or theta R?
Theta R.
Theta R. So let me put in some test values into this. And I'll give all you a question to do. And I know what to expect. Theta R supposed to be bigger. It's supposed to be bigger than theta I. We know that. So if all they do together, something wrong. So question. Aliyah, what are angular incidence looking like? How much degrees are looking like?
Like at 30 degrees? I don't know.
I was going to see as well,
Yeah.
right? Find the angle of refraction. Yeah, so I want you guys to try this question. Find the angle of refraction. You have 10 minutes. 10. Nicholas, I guess you know do critical angle and thing already.
Yeah, we already know critical angle.
All right, lovely, lovely. So Justin, just remind me, the density medium, you think the refractive index is going to be higher or smaller?
The density medium
Yeah,
will be lower.
nine, we higher. Look at it. Um, the refractive index for air is 1. It don't get higher than that. 1 is the highest,
Oh, okay,
right?
yeah.
Because light does travel at its maximum speed in air, right? So is the higher the refractive index, that means the slower light gonna move. So if I tell you, well, diamond, I'm gonna tell you diamond refractive index. Okay, the refractive index for diamond is like 2.5. Diamond is the densest material on Earth. I think it's like one of, did you know that?
No,
Yeah, diamond's very heavy. Yeah, diamond is not the densest material on Earth, but it's one of the most densest. So basically, since diamond's so dense, it will real slow down the speed of light, like real slow down. Real. So the higher the refractive index, the denser it is. The exact sign multiple choice. Right, so Nicholas, I expected answers from you pronto because you know what to do. They're ahead of the curve here.
Yeah, join the diagram.
Right. Hmm. Yeah, how things going?
Going okay.
What do you think about this topic so far? Like, it all right?
Yeah, it's okay.
Hmm.
It's
Once,
manageable.
once I could do this, and I'll show you about critical angles and internal reflection, or we can handle any system question. Supposed to.
You see about the formula using the last question.
All right, let me read the formula. The formula you had to use is Ni sin I is equal to Nr sin I.
That feels something I do in that question wrong, and I get 50 as it.
Yeah, you did something wrong there. Um, Let me explain what went on. In the first page of Sunma, you have 1.5 sine 30 is equal to 1 by sine I, right?
Okay, right?
Where did the 1.5 go? That's the question. Where did the 1.5 go? Hmm.
Oh, oh,
So, let me tell you where I had to do. So, it's a new page or somewhere to do the working or continue the working.
right,
So, you have 1.5 sine 30 is equal to 1 sine R, right?
right,
Cool. You can simplify any other line. So you can say 1.5 sine 30 is equal to sine R because what is 1 by sine R,
just sign out.
right? In a real good situation now. Look at the previous question. From that point, if I want to find my answer, I find the inverse. So watch. I have sine R is equal to this whole thing. So if I want to find for R, I find the sine inverse at the whole thing. You understand?
Um, yeah, yeah. See why I went wrong.
So you just have to find sine inverse, everything on the other side. And again, you're looking for a bigger angle. At that'll be bigger.
Um, it's not related to the physics, but when your calculator not working or coming on at all, unless you're like facing it towards a light or you're flashing a light on it or something, but I mean,
How many battery dead?
so that's what going on with my calculator.
Yeah, you gotta change that battery.
That sounds like last month or something.
Where is it?
Ever since like last month or something.
There's a sign to get a Casio. Switch up one time.
I got it.
Yeah.
I get 45.
45. Nice. Okay. Send me a working.
Okay.
So me know what I do in room, but I still getting something smaller.
Justin, does he?
Yeah.
So send my picture I will get, and I will show you where show you where you go from. Wait, Alia, where you get 45 from? You multiplied 30 by 1.5?
Yeah.
It don't work like that, you know. Sine 30, sine 30, that's a number by itself. Put sine 30 in the calculator for me. Put sine 30 into the calculator for me. So like, I see all you understand the physics. It's just the maths given on each other. It's the maths all given on each other. All right. Alia, you put sine 30 for me?
Yeah, I sent in a get.
You get a half, right? Okay, 1.5 sine 30, right? That is 0.75. And now one way to try. Now I noticed that you said sine 45, right? You said sine 45. I want you
Yeah.
to put sine 45 in the calculator. If you correct, you're supposed to get 0.75 as well, right?
Oh, I didn't get it.
You see, I'm gonna explain why. Sine 30, sine 30, it's looking a bit funny, but that whole thing is a number. That's our whole term. You can't mess with anything on the inside. The angle is 30. You can't multiply that by anything, right? I want you to put sine 30 in the calculator for me by itself. Let's put sine 30.
I got half.
So you see, sine 30 is a number by itself.
Yeah.
You can't interfere with that, right? You cannot interfere with that. So where has sine 45 on thing, you gotta erase that.
So you just put in that over 1.5?
1.5. Nah. Yeah.
Or
The second line you have, let me show you what to do. I will show you what going on. So it's the maths what you're running on in trouble. Um,
Nice. I signed the join math lessons.
um, Nicholas, you get the correct answer. You did get the correct answer. But I would have, I mean, I understand why you're calculating and then doing that because you don't have a Casio. But I'm going to show you I'm going to show you the proper way to do it on the board. But that's correct. You're supposed to get max. But show you a way to get even more accurate answers. Right. So Aliyah and Justin, what are you pay attention? So Aliyah, I want you to call out the second line from when you plug in everything.
um in brackets 1.5 sine open bracket 30.
I'm ask you a question. Can you interfere with that city inside that sign?
No.
You can't interfere with that. Because sine city that's a number by itself. And
Yeah.
now well to what?
1, well, open bracket 1 close bracket sine r.
Right. Let me simplify in the next line. 1.5 sine 30. What is 1 by sine r?
Sine r.
Right? Now this probably looking confusing. So what you could do is you could flip it. So I could write sine r is equal to 1.5 sine 30. Now I want to find for r. So what I have to do?
um
Take
You
it.
sign inverse.
Yeah, you sign inverse. Check it out earlier. Anytime
Yeah.
you have to find for the angle, you have to find the inverse function. So it'll be sine inverse. So it'll be sine inverse of this whole thing. So it'll be sine inverse 1.5 sine 30. So plug that into the calculator and you get a correct answer. All right, so Justin, I want you to tell me, how did 1.5 end up in the denominator? In the top line, it was 1.5 by sine 30. How it end up in the bottom?
No, I write it wrong in my book. That's why like,
That's okay. But let me show you something. If you have 5 by 7 in the first line, right? 5 by 7, that's 35, right?
right.
In the other line, you can't say 5 over 7.
Yeah, yeah.
Can't do that. So watch this. And as soon as you end up at this point, where it just has sine r, the only thing you have to do again is just find the inverse of whatever on the other side, and you'll get your answer. So
Right.
put that into your calculator and let me know what you get as the answer.
Okay, 48.59 or 48.6.
So r is equal to 48.6 degrees approximately.
Yeah.
And that's the 3SF. Ali, I just confirm this.
Yeah.
Right. So
Yeah.
yeah. Mm-hmm. It was
No,
another question.
no.
All right. Just close. What? All right. Let me give Ali another question. Ali, how to get this right? The maths is what killing all that. Not the physics. Right, but Ali, it makes sense, right? We know this how to be bigger because it's bending our way. I mean, if you catch that,
Yeah.
right? Any good physics teacher supposed to be able to teach maths as well. Vice versa. That's why most math teachers is teach physics. Oh, Rocky just teach maths.
Nah, no wonder why I just do any test.
Oh God, I don't know why I'm saying so much bad thing about the fella. Oh, yeah.
I don't find him as teach good.
No.
You should come at the end school and sit down in one of his class and see what this be.
Huh. All right. My pull up and Shiva boys.
Yeah, I don't mind come back. You go see all them teacher and them.
I will check all the math teachers on them. All the math teachers on them. I real cool with them. I'll check my father-in-law too.
We my teacher is Navin Lal and it have what was that Shobha Puran and it have
So why is he boss? Yeah.
it have Priya so crash too.
Eh,
But me and if she gonna know Priya is a new
I
teacher. She come in recently.
I know Priya. I know Priya. I'm not that old, eh? I'm not that old.
No,
I
no, no, me ain't saying that. Me ain't saying that.
I know that old. But I know Priya. Yeah. Right. So Alia, let me switch things up a bit, right? Gonna switch things up. In this question, I'm changing up things a little bit. I want somebody to show me what the I want somebody to show me what the normal would look like in this case. Show me what the normal
Um,
would look.
I let me real.
Listen? Yes, yes.
I
That,
never mind, never mind.
no, that's correct. That's correct.
Yeah,
I take
I
that.
was on the same thing.
That's correct. Um, Alia, where you want to go to? Water to air, glass to glass. You could say anything. Where you want to go to?
Air to water.
Air to water. All right. Air over here or air over here? Where would the air to be?
Air on the right side.
And it went from air to water?
Yeah.
Okay. So I want you to draw incident ray. Draw incident ray for me.
Me?
Yeah, draw incident ray.
Okay. Um, waiter.
All right. You take that. Right, what angle are looking like?
Like
We're just gonna sing a Marsha Montano, Marsha Montano song there. Like a, you know that song? Every day is fat.
yeah.
What the fat? All right.
I don't know. A 50. No.
It that look like
I don't.
Say, I used to that's 55 or something.
yeah, I would say 55.
Yeah.
And since it going from air to water, that is my incidence or my refracted.
The
It
incident.
right, because it coming in, you know?
Mm-hmm.
I gonna cross the boundary line. Now it going from a what to a what? Less to more, more to less. It going from air to water. So what was
More
that?
to left. No, wait, hold on.
You
Yeah.
take you say more to less?
No, wait, hold on. Wait.
All right. Take your time. You what in this, which one then, sir? Air or water?
Water.
Water. So you're going from a water or what? Feel like you're real hot in your head, Real
From
hot.
a water left?
From a more to a less?
No, we're going to no, from a less to a more, yeah.
So if you're going from a less dense to a more dense, it will bend that way, you bend towards.
Towards.
Right, bending towards. So show me what the angular refraction will look like. More refracted ray.
Okay. Not so much, huh? But that'll work.
We can work with that. Yeah, we can work with that. I would take that. And I'm measuring this angle over here.
No.
No, it's always measured from the normal,
Yeah.
right? Right, so I want you guys to find the angular refraction. By now, well, you should know what the refractive index of A is. What is it? N is equal,
One.
and well, the refractive index in water is,
1.30.
yeah, right? So find the angular refraction.
So now I see why me now I enjoy talking to Aliana because she is the cricket honey.
Wait, sir?
I see why you tell me I go enjoy talking to Aliana because she took the cricket honey.
Yeah, and she good in physics.
Hmm. Well, me I got any physics yet, so she got help more honey.
So I good in physics.
Yes, sir. I mean,
Okay.
I find physics is an easy thing, you know. Once
Well,
you
yeah.
once you
But
get
you
at
know your
maths,
work.
maths is what giving all the trouble. That is the only thing that's stressing on it. That maths falling on the back bad.
So I just saying I don't like nobody that can't draw it. So I hope
What going on here?
huh? Nothing. I just being honest.
I don't know what's going on here. Hmm.
Mm.
I just being honest.
Awkward
I don't
silence.
know what's going on here either, yes.
I don't know what's going on here at all. I don't know.
Sounds strange.
There's a disturbance in the air. Anywho, I give it like 10 minutes first.
So yeah, man, then the wrong variable saying I confused no discussion. Try
You're
to
wrong.
time up.
Is the same concept?
Yeah, I know, but I was watching it upside down, so you almost confused me.
Ah, hey,
But
in the exam, they were trying to confuse
I,
the boy, you know.
nah, I dedicated to my physics, so I understand.
Nice, nice. Plus, you sent me answer already? Oh, yeah. I will check it. I will check it.
Also,
So, Nicholas, the only problem I have with your working is I using rounded off values as the one thing that I might lose marks for.
with this,
Rounded off values. Look at check it out. In my working, I didn't use any rounded off values. Up to this point here, I use the exact expression. Now, I understand it's a bit hard to do that with the sharp, eh? So I'll give you a blind. I'll give you a
hard.
blind. I'm gonna check your working. Yeah, Nicholas, that is correct. But yeah, you might lose marks for using rounded off values. Might. But the working is correct. Excellent. So this could be the last question I do on this. And then we're gonna look at critical angle and then total internal reflection. Aliyah again, true?
Yeah, almost done.
Justin, how about you?
Trying something.
All right. I'm coming back in 5 minutes. Use your extra time to get the answer. All right, I'm back. I don't know if you guys hearing, man.
Yeah, yeah.
All right, Justin, that's you.
Yeah.
Justin, you get the correct answer, but I want to, you do your working wrong a little bit. I will show you when, but you get the correct answer. Just some part of the working, yeah, yeah, you fumble it a little bit, right? But still get the correct answer. Ali, are you there?
Yeah.
I want to say that's the model solution. Yeah, as the our 720 chance.
Okay.
So the fellas kind of learn from you.
Yeah.
Yeah, guys, this
So
how it.
you so sure what I said?
Yes,
Watch my weekends.
it's proper working. That's perfect working. You don't get better than that. That's why I do the working. Yeah.
Hmm. I thought I was just a student. All right.
Oh Lord. We things think have some bacchanal here. Oh Lord. Hey.
Nah, it's no bacchanal.
I go I will show you how to learn the ways of perfection. But you get the
All
question.
right.
You get the question. I feel like you're coursing on my day, you know.
Me?
Yes,
Me or
so
she?
hey, all right. So Justin, little
Yeah.
random question, right? What's the formula I have to use for this? My formula?
Formula is Ni sine I in brackets equals to Nr sine R in brackets.
All right, and just remind me what let's call this. What do you name of this law? It's our S.
Now, so
Yep. All right, big up you. And the incident rate. Where's the incident rate? Where is it?
incident ray,
Mm-hmm.
that's an A.
That's an air. So my refractive index there is 1. What's the angular incidence?
Angle of incidence is 55.
Right? And that's equal to what's your refractive index at of for your refracted rate? Your refracted rate is in water. So what's your refractive index? So that's
1.30.
right. 1.20 sine R. Right. Now, mind if I pull up your working? I just want to clarify something soon. I can pull up your working?
Who's my weapon?
Yeah. I just want to show you
Yeah,
something. All right.
yeah.
1 second. Don't feel any way I'm thinking. I'm proud of you.
No, no, no.
Question correct.
Yeah. Nah, I know I was just a student.
Lord, the shade, eh? Hey, the shade. Hmm.
I staying
I
quiet. I like to
I
listen that.
no, I sit in box.
Sure.
I feel like sunglasses here. The amount of Lord. Whew. Ah, all right. So this is not a shame
Oh,
thing, eh?
what my scrappy and I
I will tell me how you went from this line to this line.
take a rebucket.
I will to tell me how you went from this line to this line.
Oh, I went it.
Yeah.
I watched the first one we do, and I do it.
Oh, wait. And I'll see what you do. So To get rid of the 1.30, you divide by 1.30 on both sides,
Right?
and that would have cancel off. The one thing though, how come you write sine r is equal to over here? One thing.
Oh, no, I was gonna do something else, but I realized.
So you see what you have over here?
Right?
That's perfection. That's awesome. Just get rid of the sine r is equal to,
All right.
and we'll take that any day. That's perfect as well. It just
Right.
that sine r
Mm.
can throw them out under the bus, right?
No, no, mistakes I made.
Right. So uh Nicholas, you see how I'm using the actual value like sine 55 over 1.30 and plugging it into the calculator. That's what I'm talking about. Yeah.
Yeah.
I see you rounding off your values first, and then you keep on using your rounded off values. You might lose some marks to that. 1 or 2 marks. Yeah, right? But you get any answer, so right. So let me do this question on the board quick, and we will move on to total internal reflection and critical angle answer. That wouldn't take too long at all. I promise. And yeah, you feeling nice here? Feeling real nice?
Not real nice. I feeling nice. I wouldn't overdo it.
All right, all right.
Just feeling nice.
I feel like
Okay.
Justin over there with a gun and all, he's like,
I, in my corner, quiet.
oh gosh.
You sure you're quiet?
Yeah, yeah.
Hey, here is beef.
Whoa, this is well done beef. It's not a rare steak kind of thing. It's like proper beef. Way boy. Forget Mike Tyson and Jake Paul. This is Aliyah and Justin. Way.
I
I don't know what
know.
does he have against me, but he have against me. So
I
nothing.
have
That's it.
nothing. I have nothing against nobody. I am a good boy.
This beef
Yeah.
better than Kendrick Lamar. Sure.
For real. For real. Hey.
More reggae here. Coverage of all this track.
Yeah, yeah, yeah. You hear how Eminem this Megan Thee Stallion?
Yeah, yeah,
Really?
yeah, you know.
Yeah. Justin is the next Eminem, you know. You gotta watch out.
Serious Slim Shady.
Yeah. 6 years. Hey. Oh, yeah, that's entertain me, honestly. I know this
You
some
know what? You know what I do for that girl there? Me so me do nothing. I know I star student from the beginning.
Okay.
oh my god.
Oh,
Well,
okay. Okay.
hmm,
See, sir, she hating on me now.
You feel okay, whatever. Okay.
oh my gosh. I nothing.
I'm
Yes.
not gonna say nothing.
I
I quiet.
all right.
Sure.
So we do our good bits of questions. So let me explain critical angle. Right. Let me look at critical angle. So I didn't expect it to be something, but wait. Right. All right. So I have a boundary here. Right. Let me just say that this is air and this is water. Right? And Aliyah, let me say we're going from water to air. So that is our less dense. What was that? What case is that? I want you to tell me
Um,
what case is
more
that.
dense to less dense. Yeah.
Justin. Justin, when we going from more dense to less dense, what has happened to the refracted ray? It is bent away, it's bent towards what has happened?
More than Celestines,
Yeah, more dense to less dense.
we bend towards the normal.
Nah, it's bent away. More dense to less dense.
Shocks, confusion.
Right? So let me explain that one more time. I just put a note to the side here. More dense to less dense. The refracted ray bends away. Right? So Justin, I want you to show me how we go bend away. Do a sketch of the refracted ray for me.
Starting back to think that I is not a star student again, I'll give she credit.
What?
I feel nice now.
Yes. All right. Yeah, that's correct. Ali, I just quiet here.
Mm,
Alasnan.
I given she credit, so she had to get quiet.
I don't know what's going on here. Well, let's
Okay.
rocking back and eating popcorn here, honestly.
I feel Nicholas doing the same thing.
I dead and laughing and ako na hiya boy.
All right.
You know his jokes are like no one eat man thing.
Mm.
Hmm. So, guys, if this is the case, well, which angle is always the bigger? If you're going from more than to less dense, what angle is always be bigger?
The angle of incidence.
Nah.
No, a lie.
You're going from more dense to less dense, so you're bending away from the normal. The refracted
The
ray.
angle of refraction.
Right. So theta r is more than theta I. I'm gonna take the same diagram and adjust it. So here what, right? Aliyah, if I take this angle over here, if I take this angle and I make it bigger, what will happen to this angle over here? It will move like this, it will move like this.
It will move to the left.
Like this,
Yeah.
by bending away from the normal though.
Wait.
Watch. Let me show you what's happened. Yeah, I don't understand this
So
concept.
if that one moving away from the normal, then the other one would move towards the normal.
Remember, you're going from a more dense to a less dense.
So move further away.
Yes. Watch this. So let me show you why that's going on. Let me just say this angle is I don't know 15. Then this angle had to be less or more.
More.
More, so it gotta be 20 or something, right? I don't know.
Yeah.
And well, if I make this bigger, then you think this could get smaller? Or it'll get bigger?
What you say?
I gotta explain that back one more time. So
Sorry, repeat.
you understand? The angular refraction always bigger.
Yeah.
So what? If I make the angular incidence bigger, what you're saying that this could be smaller? Some of that makes sense.
No.
It always had to be bigger, so you gotta get even bigger.
Yeah.
And it go reach a point to where it gets so big that this in line with the normal, like that. You understand?
Yeah.
Let me explain that one more time. Nicola, didn't you understand this concept already?
Yeah, I understand.
All right, Justin, check it out. And Aliyah, I want you to pay attention as well. So, Justin,
Yeah.
I'm going from water to air. Water to air, right? Water to air. If I'm going from water to air, your refracted ray gonna bend towards the normal, it's gonna bend away.
Repeat back.
If I go in from a more dense to a less dense, a refracted ray, will it bend towards the normal or will it bend away? I go from a more dense to a less dense. More dense to a less dense.
Bend away.
Bend away. So what angle had to be bigger? The angular incidence or the angular refraction?
Refraction.
Right. So I'm going to gradually increase. Wait, let me just explain that one more time. So Justin,
Yeah.
if I were to increase my angular incidence, what happen to this? Would it get smaller? Would it get bigger? Smaller or bigger?
Smaller.
No, but then that will break the rule. If this
Yeah.
gets smaller, then well, this could be bigger than this now. That will make sense.
Oh, okay. Yeah.
Because here the rule again, right? If you're going from a more dense to a less dense, the light ray, the refracted ray bends what?
Bends away.
It bends away. So bigger the angle, the more it will bend away,
All right. Yeah, you catch me. Right.
right? Aliyah, explain that to me.
What?
Oh Lord,
What you say?
wait. If I increase my angular incidence,
Mm-hmm.
will it decrease my angular refraction or increase it? Let me do a simulation, right? Let me do a simulation. So look at what's going on, right? At all times, my angular refraction is supposed to be smaller or bigger?
Bigger.
Right.
Refraction?
Yeah.
Supposed to be bigger, yeah.
So if I increase this, I will have to increase this.
Yeah.
And eventually, eventually, this is what's gonna happen. Watch. I increase it here, I increase it here. Look at that. You
Yeah.
understand? No?
Yeah.
Okay, sure.
Yeah.
All right. Justin, you sure you understand now?
Yeah.
All right.
Being studious is the key.
Yep. Decide.
So she really vexed with me.
I don't know what's going on.
Right, I don't know either. I quiet.
Ali, I'm going to shoot a no just now, you know. Watch and see.
She go kill me just now.
Want it? No.
I never do anything. I am a good child.
Sure.
All right. So, let me test all you. I want to, I have some beef and thing. Let me test all you. Right?
Gosh, it, I no beef. Relax.
It really don't. You don't need to test me. What you talking about?
Um, all right. So, Ali, I'm gonna test you first.
Oh my god.
Uh,
If if I were to make this smaller, right?
Mm-hmm.
So I'll make it better. So this 1 second. So I'll make it smaller.
Right.
What would happen to my angular refraction?
It would get smaller, but not
It gets
not
small.
smaller than the angle of incidence.
Yes. Yep. Correct. Like, like
See, I got
physics is your calling. Yeah.
right.
no. She got it that one. Relax, relax.
All right. Time to test you, Justin.
Yeah.
What?
If I make this bigger, like watch, if I make the angular incidence bigger, what will happen to my
Right.
angular refraction?
It'll get bigger.
Right. It'll get
Ah,
big,
see, she got it from her.
It's
right?
not hard. It's not hard.
So
Come on.
basically what I'm trying to say is if you make one smaller, the other one will get smaller. If you make the other one bigger, the other one get bigger. Simple. Simple.
Yeah.
Simple, simple thing.
Yes.
And eventually, if you make it so big, it will the angular refraction, it will eventually line up with the normal. Sorry, not the normal,
Yeah.
the boundary line. The boundary
The
line.
bound.
And then the angle will be what? The angular refraction will be what then?
0.
0. Remember you
See?
did the angle from the normal, eh? Wait, so watch this. This over here is my angular. It's these my angular incidence, but I'm gonna call it theta C, right? The angle of incidence that gives you 90 degrees. That's a critical angle. That's what we call it, critical angle. All right, so this is the critical angle. And a way to measure this angle, what our angle looking like? What is angle looking like? If you were to measure this angle, tell me just
90.
90. Yep. And we refer to this as the critical angle. So when you bend, so when you're in, if you increase your angular incidence big enough, eventually, the angular refraction will line up with the normal. You understand that?
Yeah.
Only you understand that?
Yeah.
And let me ask you, let me test all you again. If I increase the critic, if I go past the critical angle, what do you think will happen then? If I make this bigger, where would this go? Where would this go? Would it be like this or would it be like this? One or two?
Um.
One or two?
Two.
Right. Because eventually it will bend so much, it will pass the boundary line. And at
Yeah.
this point, you have something called total internal reflection. Because let me ask that question. At this point, right, Aliyah, is it going from water to air or going from water to water?
Water to water.
Yeah, going from water to water at this point. And we
Yeah.
call that total internal reflection, right? And at this point, we have reflection. So theta I, this is theta I. When you push past critical angle, the refracted ray ends up back in the other medium. And total internal reflection occurs. So make a wild guess, Justin. If it's reflection, theta I, let me just say this was 45 degrees. How much degree do you think this could be?
45 degrees.
Yep, because it's total internal reflection. It reflected it. Same angle, everything. Alia, do you understand the concept?
Yeah.
Right, so I could copy this down for critical angle. So this over here, this is the critical angle. And let me just show you the piece of calculation associated with it. So the angular incidence that gives a refracted angular refraction of 90, that's a critical angle. So let me explain how to do this. The formula is Ni sin I is equal to Nr sin R. Right? You go from water to air. Where's the refractive index of water? Anybody remember the refractive index of water?
1.30.
1.30. Right? And the angular incidence, we're going to call that theta C. Right? Because at that point, let me explain what. Justin, and when I make the angular incidence bigger, the angular refraction is also get bigger.
Yeah.
So when I push it past that point, eventually it is line up with the normal, right? Not the normal,
Right.
the boundary line.
Yeah.
So this is my angular incidence, but I call it theta C, right? The angle that give you 90, we just call it the critical angle, theta C.
Right. Right.
The refractive index at air, that will be 1. And where's my angular refraction? When I add the critical angle, where's my angular refraction? Always. What angle is that?
No, 90, 90, 90.
Right. So when you add the critical angle, the angle of refraction is always 90 degrees. I make a note to the side. When you are at the critical angle, the angle of refraction is always 90 degrees. So that'll be sine 90. Could somebody just tell me what sine 90 is?
One.
Right. So I'm going to put 1.30 sine theta c is equal to 1. Right? And so if I wanted to find from a critical angle, how would I go about that, Aliyah? If I wanted to find for the critical angle from air to water. It's the same things as the calculations above. You have to find the inverse and thing. So I gotta do what on both sides. Before I could do anything, what I do on both sides?
Divide.
I had to divide both sides by
Mm,
what blocking the sine theta.
be 1.30.
Right. Right. And when I do that, it will cancel off. So sine theta c, that will be 1 over 1.30.
Mm-hmm.
And to find my critical angle now, theta c, that will be equal to,
1/1.30.
take your time, not quite. So I had to find theta c, that angle. You're missing something. That'll be sine,
Inverse.
right? So plug it into the calculator, 1/1.30.
You'll get 50.28. You could round it. You could round it, or
Yeah,
that'll be 3.
50.3. Right, so that's the critical angle. That's the critical angle. So if you have a light ray incoming and is an angle at 50.3, it will be in line with the boundary line. And if you push past that, it will have total internal reflection. Yeah,
Yeah.
right? So one more time. If I increase my angular incidence, what happens into my angular refraction?
That increasing.
That's
Too.
increasing as well. Correct. And eventually, if I increase it enough, granted,
It could touch the boundary line. It could reach the boundary line.
and at that point, we call it the what? So like, what's going on, right? If I increase this, I want to increase this. I increase it a
Yeah.
little more. If I increase it a little more, it will line up here,
So that'll be 90. That'll
right?
be the 90 degrees.
And I'll call our angle the what?
The critical.
Angle, correct. And if I go beyond the critical angle, it's gonna dip back into water, and at that point, it's gonna reflect.
Yeah.
Yeah. Right. So that's the concept there. Right, Justin, you want to run through the concept with you again?
Yeah.
All right. And don't worry if you left out on singing. If you
No, 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 no.
ask on singing.
Hey, hey, hey.
Aliyah laughing real evil boy. What do you have?
She evil.
Aliyah,
I'm not evil.
You're lying.
I'm not. This is my first class since. Okay, relax.
Uh-huh.
like all they know each other in real life or something?
Nah,
No,
Oh,
she gonna kill me in real life.
perhaps.
that sound like Kiera and Nicholas.
And that's why I see it.
Uh,
That is what I
Yeah,
do.
yeah, but
You
I don't know
know,
him in life.
yes, they are secure.
Yesterday.
Something she do. Oh yeah, yeah, yeah. She was sleeping, man. She gonna make me buy some quick cookies for she.
She go broke, see you know. Here we broke.
I slave Bryce Tuesday. I use him money when we walk down the hill. I buy a slushie with him money.
Eh,
No, I buy ice cream. Yeah, I didn't buy a slushie. It was ice cream.
I just voluntarily give my sister money to buy
And
everything.
and I make him hold my bags.
Fair game. Fair.
You know what she do?
What she do?
Rain was falling, right? And this girl, well, she make me do it, but I do it was at the courtesy of my heart. Me and one of she other friend was working one of we mutual friend. But we'll always you know she is Alicia, right? So
Yeah, Alicia.
rain falling. So I get him my very good, very beautiful red jacket because the rain was falling and my jacket thick. So I threw it away to them. And I walking in the rain, I getting soaked down.
That
Oh,
is
that's
gentleman.
sweet. Yeah.
That is chivalry. They got
But
peace.
right after we start to walk, like about 5 minutes after, then the rain stopped.
You know,
So
Bryce
yeah,
will never do that for me.
Hey,
Yeah.
hmm.
Sasha would faster do it for me than Bryce, yeah.
Yeah, Sasha, go do that.
Yeah, Bryce could study he and all kind of thing.
What's here?
The little bush he have growing on top of his head.
It's a see the kind of thing we decided to do for them, you know? And yeah, no, stay quiet.
I don't know
Oh, why
about
you
you,
say it
but
like that?
it's something it just want to do wooden being. Like it's a wooden thing. You gotta do it from the kindness of your heart.
Uh-huh.
Bryce, Bryce don't have the kindness and he had to do that.
You
Yeah.
could do it for someone like you that he never met
Yeah,
in life.
yeah,
Yeah.
definitely.
I do open the door and thing for my sister. I just tell she can. She could open the door and thing for herself.
Exactly.
Bryce would do the same thing.
My girlfriend though, I'll get on my knees and thing and I'll open the door
Oh,
and like, yeah.
yeah. Well, he girlfriend the friend, right?
I can't think.
I today I went and pick up my sister, right? And when I answered the phone, I was like, am I speaking to a smelly rat here? And she had it on loudspeaker and everybody heard that.
Oh my, you embarrassing girl.
Sister is an embarrassment. Hmm. I saw she was saying the same thing about me. It's kicks though, it's kicks. I already mean it. I love my sister. We just kicks, it just kicks. I mean it. Maybe I do, maybe I don't. I don't know. Hmm.
Yeah, I feel the same.
Right. So now,
It's all love and hate.
where's it?
It's all love and hate.
For sure. For sure. So once I copy this down, next class we just had some past paper questions. That's all. And like we good.
You could zoom in,
I
please.
will zoom up to this piece. And when you finish
Yeah.
on this, I will zoom into the other part. I feel like a large population of physics teachers don't know what they're doing. I remember
Rocky included.
to say about it, man, but like I remember doing lower six physics and thing, and then upper six physics and asking questions, and then them couldn't answer me. I was like, what? How that working? Them like, them know. Uh, and yeah, and she wanted to be a teacher.
Wanted, but
A little
not
physics
like,
something.
uh,
Physics something.
not a secondary school teacher.
Think it's too
I
much
like
stress.
children. I like small children.
God,
So like it wasn't gonna be secondary school.
small children are the root of all evil. I swear to God, I hate them little buggers. I they like this so evil. Like here this earlier. Here this. You had an accident, right? And the car flip over, or they didn't flip over, but it went down. You know all that, right?
No, I was not informed. Also, if you hear noise in the background, it's Bryce.
Oh, well, here this, right? So basically, I skid off the road. Rain was falling. I had oil on the road and thing, and I skid off and I went down like 1.5 meters down, right? Into like a decline.
You
And
okay?
yeah, I find my girlfriend was fine as what are we fine.
Okay.
But here it is. Them
He
it have a bus of small children and them laughing and pointing and saying, boy, hey, small children is the source of all evil. I
You're
I
lying.
I not lying. You see them small
That's
blue
so mean.
like the blue uniform children?
Stop
I don't know.
it.
I don't know.
Um,
Nicholas, you like small children?
no.
Why? Well. Me know how to answer that because sometimes I'll be babysitting and thing, and there's be normal,
You don't.
and then other times there is be like care.
Justin, what are your thoughts? We like small children.
Basically the same thing as Nicholas.
I hate small children, yes.
Bryce, Bryce trying to talk to you
How are you
for like
going?
for the longest while he trying to get your attention.
What is it?
He calling you out.
Oh, oh.
He say, "Yeah, short man."
Yeah, here. Olha aí, copy down. Olha aí.
I don't know.
All right.
I almost done and the second one.
Bryce is a clown though.
You hear what he say?
Justin, you have this copy down?
Yeah, I finished.
Nicholas, what about you?
Yeah, finish.
Right. Alia, you finished copy this down?
Yeah.
All right. Next part. All right, Alia, you copy this down? Justin, come on if you're there.
Yeah, I almost finished on the second one. Yeah, I finished.
All right, see no more. See no more. So Nicholas, as you.
Nah,
Yeah,
Justin.
I
I
have
get
both of you say yeah. So both of you have it on. So Nicholas,
Yeah.
like you fully understand it now, like nothing confusing you at all, right? Like 100.
yeah.
All right. And Justin, what about you?
Yeah, it's simple, it's simple.
You understand what refraction is now?
Yeah.
Right. And Alia, do you have everything copied down?
Yeah.
All right, nice. Ooh. Well, guys, I hope all you have a good night. Also, only have one or two questions. Yeah. By the way, Nicholas, I never get a hard man to work from here yet.
Tell me about art math. She said she would send it before class start.
What? I still waiting. No way, boy. Way.
Yesterday she told me after, so we go see.
We will see for real. Well, later, guys.
Yeah,
Hope you
that's
have a good night. Later.